Today we're going to talk about the Next Generation Beacon program and an update on what's happening with the beacons. So the Bethlehem Beacon is a test beacon that has developed an intermittent problem, and this was getting progressively worse. So we took the decision to recover the beacon and take it off air for it to be repaired and refurbished. The beacon monitoring system development was also progressing very well. However, with no beacon running and no beacon to monitor, obviously it makes development a lot more difficult. So the Karoo beacon, the planning for the Karoo beacon had already started, but however we had some bad news. There's a shortage of components, which means that the next generation beacon hardware could not be built. And the hardware needs to be redesigned around what is available. Now this is causing us a bit of a headache. So let's just discuss why is the problem there. So the first COVID-19, firstly we had COVID-19 happening that resulted in most of the world shutting down, including component manufacturers. And secondly, there's a trade war on the go between the US and China. So as a result of both these events, the world logistics has also become bogged down. So there are containers standing around that are not being unloaded off ships. Raw materials are struggling to move around the world where they're supposed to go to. And of course now we've got the Russian invasion of the Ukraine as well, which also affects component manufacturing, because a lot of the neon gas that is used in chip manufacturing actually comes from the Ukraine. And with the war going on, there's no or very little supply of raw materials again. So yeah, this is a big problem for us. And the result of this is that we actually, anything that we look for, it's out of stock. Even locally here, things like a Raspberry Pi. If you try and find a Raspberry Pi in South Africa, you're not going to get it. Here and there you might find one or two still, but generally you can't get any of the stuff that you're looking for. But radio amateurs are resourceful, and we try and make a plan always. We make use of the opportunities to overcome the challenges that we have. So what are the alternatives if there is a shortage of components? Back in December, about the middle of December, Nigel ZS6 Romeo November found that QRP Labs have a U3S Whisper beacon kit. And we discovered that this beacon kit has been designed to be able to do a number of different modes, including PI4, which is the mode that we use for the next generation beacons. Then the next question came is, can they do the job? Nigel and myself started doing a paperwork exercise, trying to evaluate or do a comparison of the two types of beacons. The next generation beacon that was designed by the Danish guys, the Oscar Zulu guys, and then obviously the U3S. And we found that we were getting nowhere. And this was because the design is totally different. The Oscar Zulu next generation beacon hardware. This uses the SI53518 chip, whereas the Oscar Zulu beacons uses DDS chips. So that's the first major difference, is in the design. The U3S beacon is a very much smaller footprint than the Oscar Zulu beacons, and you can see there on the bottom right there's a picture of the beacon hardware in its casing that we've put it into, and you can see the size of it there. It's actually very, very small compared to the other beacon hardware. The other nice thing about the U3S, that it can be programmed on the fly. There's buttons on the front, and you can just reprogram it or change parameters as you see fit. However, we found that it's not stable. It's not as stable or frequency accurate as what the Oscar Zulu beacon is. And there's different tricks that we've done to try and get it stable. Obviously on the lower frequencies, on HF frequencies, you can get it spot on, very stable. But as we go up in frequency, so it becomes more challenging. And you can see as well there on that picture there, that beige that you see there's a small polystyrene housing that I made that fits over the synthesizer board. Try and keep the synthesizer chip and the crystal nice and warm, and to keep its temperature stable. And also what I've done is I enclosed the whole box on the inside with high density foam, which also helps to keep the temperature nice and stable inside the box, because we found not only is the problem with the synthesizer chip, but even the GPS chip on the GPS board, that is also heat sensitive and can result in the frequency, the reference frequency that it puts out not being as accurate, and it drift around as well. So we found that if we enclose everything up like that, then it seems to be a lot more stable. The other thing we found that it can only transmit every second minute, but this is not really a problem for us. Then the other challenge with the U3S beacons, they have a fundamental frequency limit at 220 megahertz. However, I found that there's all sorts of harmonics that are present that get filtered out, and we can always take one of these harmonics and amplify that if you want to use a different frequency or a higher frequency than 220 megahertz. The other nice thing about the U3S, the landed cost is just over 1,000 Rand per kit. So that makes it very attractive. So the question is, can the U3S do the job? And the answer is yes, within limits. As long as we understand what it can't do and what it can do, it's certainly usable. Field testing is, however, extremely critical. We need to put these beacons in the field and let them run, and then we see what happens, how they perform. And this is how we've tried, done the current beacon, the current Bethlehem beacon as well. Field testing is where all the gremlins crawl out and how we can find what the problems are. These U3S beacons, if we get some of them on the air, it will allow us to continue with the development of the beacon monitoring system. It also opens up a whole set of possibilities, such as the cost allows us to have more beacons be located in an area. You know, we can put up so many more beacons for the funds that we have available. The beacons can also be sequenced to run on different time slots on the same frequency, which is great because then it means you only monitor one frequency, but you can monitor a whole bunch of beacons on that one frequency, just at different times. And the other thing, the more beacons we can have out and deployed, it means that when we are actually capturing the data, we get a better resolution on the data, as you know, once we start analyzing it. So then, looking at the way forward, there are currently 3 U3S beacons in the process of being assembled. Each will have a 25 watt power amplifier to it. They will then be used to assist with the development of the beacon monitoring solution. And also we might put a U3S beacon on the Bethlehem site, but we would need to put some more remote control capabilities on it, because from our experience on the next generation beacon hardware that was there at the site, Eskom load shedding, all this type of thing had an influence on the beacon, that it didn't start up properly, and so we need to be able to control the beacon remotely, to restart it and things like that. And these are all things that one learns when you have a beacon out in the field. So the current Bethlehem, or the Bethlehem beacon that we've taken off air, will now be refurbished and upgraded, and we'll be adding telemetry to it so we can monitor what's actually happening internally in the beacon and around the beacon, as well as remote control, so that we can then cycle the power and that type of thing. We have to thoroughly test the beacon in an environmental test chamber to make sure that it can deal with the cold temperatures that we may experience in the Karoo, as well as the hot temperatures in the summer and the daytime temperatures. So this all has to be tested before we actually put the beacon out in the field as the Karoo beacon. So it will be redeployed. The new call sign for the beacon at this stage will be ZS0 Kilo Alpha Romeo, standing for the Karoo beacon, and we'll license it like that. And the VHF work group now needs to decide on what hardware to use for the Cape Town beacon upgrade. Originally, we were going to buy 2 new Oscar Zulu beacons and deploy one in the Karoo and one in Cape Town. But now, because there's a shortage of components and so forth, we have to think differently about what we want to do on the Cape Town beacon upgrade. So the Karoo beacon status at this stage, the MOU for the site has been delivered to the landowner, and it's on the farm Elandsfontein, which you can see there in the middle of the map. That's where the beacon will be deployed. There's already a tower there. There's already internet or Wi-Fi available on the tower. It's all battery powered, solar powered, but we're going to be doing some upgrades to the site when we put the beacon on that tower as well. So the beacon hardware needs to be refurbished and thoroughly tested. We have a sponsor for the solar power upgrades that are required at the site. Now, the site's already running on solar power, but obviously when we're adding more equipment in there, we need to beef up the power. The antenna options are being evaluated. Are we going to use multiple Yagi antennas as we used in the Bethlehem deployment, or are we going to use stacked horizontal omnidirectional antennas? We're going to be adding telemetry and remote control. And this is being designed at the moment by Core. Core has taken the lead here, ZS6 Charlie Romeo. We're also busy gathering information about the physical site so that we can start sorting out what fencing and security we need to upgrade, add to the site. And one thing is for sure, the Karoo beacon is still going ahead. There's no doubt about that. We're going to install that beacon. What you're seeing in front of you is a visualization of what tunnel vision is. And I found that some of the questions or some of the commentary that is being made is, well, so we can hear the beacon, so what? What do we do next? Yeah, we don't believe that we're getting value for money out of the beacon and so forth. And yeah, we mustn't have tunnel vision when it comes to projects like that, because there's so much more behind such a project. And the course presentation that he had is also, there's a significant value that can be added to sciences. Likewise, on this beacon project of ours, this project is an ideal project that can allow radio amateurs to contribute to science. You know, the data collected can be evaluated, and when plotted on a GIS system and merged with other data, such as upper air data from the Weather Service, will provide a clearer picture as to why and how VHF propagation takes place. And it will also help us then to start understanding better VHF radio propagation and tropospheric propagation, because we do not know everything that there is, and the more we can measure and the more data we can collect, the clearer picture we can get as to, and there's new things that we can learn as well, and that we found with the HAM SCI program, where the scientists are doing ionospheric studies, and they've already told us that they're collecting data today and finding things out about ionospheric propagation that they never knew in the past. And yeah, likewise here. This project can also provide study opportunities for students who want to further their studies in the sciences. So this is the type of thing that we need to look at and and look a bit out of the box and wider as to what a project like this can provide for amateur radio and for the rest of the country.